Hello, welcome to the Neo4j online training. This course is about applying graph algorithms to Yelp data. And the goal of this course is to help you understand how you can apply these algorithms with real data and be more comfortable in doing that. We'll have an introduction to several of the graph algorithms, some hands-on practice applying those algorithms to a real data set that's very well connected, and also give you a bit of experience integrating graph algorithms into an application workflow. Our assumptions during this course is that you've completed the Intro to Neo4j training or have an equivalent Cypher proficiency. If you haven't, you may want to go back to Graph Academy and look at some of our introductory training. We also assume that you're familiar with some basic concepts around web applications. Now you may be wondering, when should I use Cypher and when should I use graph algorithms? It's not a black and white science. There's a continuum, and you can use these different tools to actually complement each other. For Cypher, you're probably considering a real-time analysis, some local decisions, trying to match a pattern. For the graph algorithms, it's more of a global analysis and something you might be doing iteratively to understand some structure and some bigger analysis of your complete network. For Cypher, an example is you would probably know what you're already looking for and trying to make a decision. Do I turn right? Do I turn left? Do I approve something? Do I not approve something? In this example or this visualization, I've got a little fraudster network here, and you can see my little fraud nodes in red. And an example of a Cypher query would be to understand, well, how many hops between these individuals, or how are they connected? And we can kind of easily see that here in this small graph. In the global analysis, we're looking at a larger view of our network, as you might assume. And there you're trying to learn the overall structure. Maybe you're updating data to be used in other analysis, and you're trying to make some kind of prediction. For example, perhaps I'm looking for disconnected components. I've got a few here, one up here. And so I can kind of easily visualize this, but often with the graph algorithms and more of that, a holistic look, it's hard to see, but we're looking for things like, what route might a disease take going from this side of the network perhaps to that side of a network? So you might also be trying to uncover vulnerabilities. Perhaps you have a network you're trying to protect and you want to know which one is the vulnerable link in your network. Perhaps you're trying to understand influence. If I'm looking at a fraud network, where's the bridge between different groups and communities of criminal activity? Or just simple community finding. Which one of these communities are more tightly interconnected? Which ones have more triangles or potential for triangles? So there's a lot of different types of analysis you might do with the graph algorithms that are, as I've said, more global. With the Cypher, you're looking at more local and real-time pattern matching. Now, when we consider the graph algorithms, there's many machine learning and graph algorithms in the Neo4j library. We've got pathfinding and search, which is often about finding that optimal path, or looking at a route, or looking at the quality of a route, which might be capacity as well. How much capacity do I have from A to B? Centrality is really about understanding the importance of particular nodes in the network. Which ones are the most important, which ones are more connected, which ones control the flow of resources in my network. Community detection is, as it sounds, about finding communities. How are things grouped together? How are they clustered together? Or how are they best partitioned? Where might they break apart? Similarity and machine learning workflow are put together because they're often used together. Similarity in particular is about looking at how much alike individual or groups of nodes are. And then machine learning workflow are often the algorithms that help us transform graph data to be used for other machine learning tasks. If you'd like more information on these, we have some online resources. We have an ebook about graph algorithms in Neo4j. We also have an O'Reilly book that will be published in the first quarter of 2019 that will provide algorithms with examples, practical examples in Apache Spark and Neo4j. If you'd like an exhaustive list of our algorithms, you can also go to the neo4j.com docs. As you can see, there's quite a few here already, and always new ones being added. So that's going to always be our most up-to-date resource. This course will start with a quick Cypher refresher and a few exercises to get you familiar with the Yelp data itself. We'll then walk through several challenges in a scenario about building a web application. We'll look at category hierarchy, and we'll use overlap similarity for that. We'll look at ordering search results using Pearson similarity for that. We'll also look at the most relevant reviews, looking at personalized page rank. And then we'll have photo-based recommendation using Jacquard and label propagation as well. For each one of these exercises, there'll be a challenge area that has, we'll start with an overview of a video about the challenge itself and the algorithms used. Then you'll have some hands-on tasks and a solution video. And then finally, a short quiz to help you evaluate your understanding in each section. If you need help during this course, you can go to the community.neo4j.com site and post questions there or search for some results. In particular, under the general area of the community, there's an online training section. You can also go to our Slack channel at neo4j.com/Slack and ask questions. And finally, of course, our documentation as well. There's a lot of developer documentations and information you can find on our docs page.